Hello, welcome back, everyone. Let's do the usual roll call for the status. People may be still showing up as we continue. Who do we have on the call? Well, let's start with Arun. You were very excited to share the news, so if you wanna go ahead.
Yeah, so we have some good news. One of our customers, Scaleway, kindly allowed us to have some residency on the data centers in Paris, France. So we rolled out a version of the CI in Europe. So folks in Europe now have an alternative location that they might want to consider. It currently has the RL300 node enabled. We're still doing some final touches on it, but all of the things are looking like it's going in the right direction. We now have eu.osfci.tech online. I've linked the relevant URL on the status update. The functionality is pretty much the same that you'd see on the US, except that it's got a few less nodes. Of course, that'll change as time goes on, but this is a good expansion to the idea of having the CI in different locations based on where the users are. Yeah, so I'll be working with Adrian to onboard the other bits that we need fairly within a fairly short click. Hopefully, everything goes smoothly. That's my update.
Very nice. Thanks for the update, Arun. I guess we'll coordinate on Slack the whole running of the diags a bit.
Yes.
Do you know? I don't know if there's been more discussion on maybe those GPUs or other resourcing that we may need to run diags there.
Yeah, I haven't heard anything since the last chat, so I guess we have what we have. Um, and if we want something more, we'd have to either onboard it on the US location or the Europe one.
Okay. Well, at least we have two physical locations now. So if
Oh
we need
yes.
to deliver something, it may actually be easier.
Yeah, so we have yeah, two different locations. We got multiple nodes. So yeah, things are looking nice from that direction, and it was quite a process to get all that approved, as you can imagine.
Cool. Okay. Thanks for that. So next on the agenda with some couple of questions and maybe a status update. Igor, you want to continue? We can't hear you. You're not muted on Zoom, but you don't have a mic signal.
Okay, so there is additional permission for mic, apparently.
Yeah, you're okay now.
Anyway, so I have a few items on the document. The first one is RS-232 diag. Internally, we have a request for this diag, and I was wondering if OCP community is interested in it. So basically, there is a RS-232 card that needs to be tested before it gets deployed in a data center. I don't know how common this is for like other data center owners, but in case this is interesting, I can think of implementing it as an OCP diag. Though internal request mentions that they want to do a loopback test, software loopback, and this will be card specific. So it may not be a universal diag with this request. Maybe we can have like a library of, not a library, but some card detection logic, and then we can enable loopback for each card separately because it's driver specific, so it cannot be universal. This is one thing. Another thing is performance measuring diag. is there any interest in running spec benchmark to make sure that certain server delivers the expected performance? This could be used for early problem detection. It's like if your cooling system is not functioning properly, you probably will have performance problems. And this can be a way to test it. So basically you would get a performance score as a measurement, and you can compare it against the spec for this particular machine and decide if it needs further investigation. Yeah, so let me know if we want to discuss it and if this is interesting. And the last item is RASDiags. I promised to deliver some slides. I couldn't find a template, so I delivered a doc. It's a draft, but we can discuss it today. So yeah, if there is interest, we can talk about it. That's it.
So thanks for the update. Maybe I can start with a couple of questions, and other people can join. So when you say RS-232 diag, this card that you're talking about, RS-232 is just a transmission protocol, like on a physical line, like the voltages and all of that. I am guessing that this card has a UART on it, right? That talks to the rest of the system on a PCIe bus, right?
Yep.
And if you say it's an RS-232 diag, what would be the scope of the testing? Like, is it something that needs like a hardware dongle, for example, like additional hardware to be able to test the RS-232 part, or is it like a whole integration test where you send stuff between two computers having these cards, and you test the whole thing end to end? Like, what are you thinking of there?
So the scope of this test initially was to test the card without having expensive equipment that is connected to this card. I mean, ideally, you would connect your device and then just talk to it over UART. And if you can talk to it, then the card is functioning properly. But sometimes you don't have this device in manufacturing, for example. So you need to test this card earlier. Ideally, you want to test the port itself also, the physical port, or like the voltage level converter. But this would require physical loopback. Sometimes people don't want it. So that's why we agreed to do a software loopback as a middle ground. But ideally, yeah, it would be a test for the entire card to make sure that when you connect it to the target device, the card is not at fault, if this makes sense.
Right. So, I mean, as far as a loopback goes, the simplest null model would be like join pin 2 and 3 on the port, right? And you get a RX and TX.
Right.
Combined.
You need to do additional action to do that. So that's why people don't like it.
Yeah, so that's why I'm asking if there is a necessity for additional hardware for this, which seems to me like there is. And even if you perform like an end-to-end test, you need at least two cards to talk between each other, which may actually make more sense because you also have like the DTS signal and CTS and the other stuff. Now, my opinion here, and again, I would invite others to join in sharing their opinions, is that we can definitely have a diag specifically for this class of hardware or this cards. I would say, it doesn't need to be like a fully generic unspecific diag like we have so far with like the CPUs and storage and stuff like that. There can be like a use case for a diag specifically for RS-232 in this example. I'm not sure that we would maintain it necessarily under the group project, like the OCP test validation umbrella. Maybe we can do that. And it depends on what other people want here as well. But that isn't to say that the DIAG cannot exist. So I do see value in having this.
I see, okay.
So for the other bit with performance measuring, I am a bit not up to date with what the SAT DIAG was doing. So Dylan was working on the stress up test DIAG at some point, right? And then he moved to another project, and you joined. I do not like maybe confirm this for me. If you are the current maintainer for the SAT DIAG, or was this part of the plan?
Not sure about it. We need to ask my management, to be honest. I mean, technically, I am probably the maintainer, but I didn't get any requests so far, so I don't know.
Okay. Yeah. I mean, this question doesn't need to be answered right now, and we don't have Dan on the call either. Maybe he had more context on this. So yeah, maybe if you want to take an action and clear this up, because otherwise we now have a DIAG which is owned by this group, and we don't know exactly how to maintain it. Now, the reason why I'm asking that is, in my view, there's obviously some overlap between what you're asking here with the performance measuring DIAG for the CPU specifically and the SAT DIAG. And maybe this spec CPU metric would be incorporated in the SAT DIAG instead of making something else for it.
Sorry, I didn't get it. How would you incorporate a spec metric into SAT DIAG? Like, run spec under the SAT DIAG?
Yeah. So I'm thinking more of the SAT DIAG as a CPU DIAG that has different use cases in it. So you could run it in this performance measuring bit specifically for what you're talking about here.
Oh, I see. So instead of creating a new project with a new DIAG, we just sort of add a mode for SAT that would run spec CPU benchmark. I see.
Yeah, I mean, it's an idea. I'm not saying it needs to happen like that. I'm just asking.
Okay, but what about this general idea of measuring performance to detect failures? Now, for example, sometimes you cannot detect failures in the cooling system, especially if it's liquid cooling, right? There is a leak, but you don't have any sensors that detect this. Then if you run performance benchmark for a long time, it will heat up your CPU and there may be some throttling so that your performance goes down, and then you can observe this and make investigation like why this performance degraded.
Yeah, that's
I don't think we do this with SAT currently.
Okay.
That actually is exactly how I use SAT in manufacturing.
Oh, I see. So
we use SAT as the load, and then we have something like a sensor monitor as the measure. And so we're looking for how things are behaving while we put the CPU under load, and what are our expected values for the heating across like all of our different heating sensors and our fans, for example. So maybe the CPU continues to behave normally when we forgot to put the thermal paste on the heatsink, but we notice that the fans all start spinning faster or temperatures start rising, but we never violate like for example, the CPU may not throttle. So that's why we're looking at, that's where we're measuring the cooling performance of the system. And SAT is the load, and we swap out SAT for whatever the appropriate load is for the given system, and that's what I always think of as the load and monitor style of test.
No, I see. So I guess it makes more sense to monitor parameters, additional parameters like temperature and fan speeds, compared to just performance metric. That makes sense, yeah.
This sounds to me more of a job for like the other topic that we were discussing last time with the composition of diags, because you could say you could configure individually, like run the SAT workloads in different ways and have the monitoring specified in the same config. Sorry, Kim, you had your hand up for a while.
Yeah, so this SAT, from what I remember, it actually used to exercise a lot of the components. It had separate threads for exercising network interfaces cards and disks and CPU and memory. And I think it is based on an underlying stress app test or some other package. So yeah, I'm not sure if this specific performance metric fits into it, but that's at least what I remember of SAT.
Right. I mean, again, it was just a thought that I had. It sounds to me like, based on what Marcos just said, sounds to me like it could be decoupled, and we could have this interaction based on a different test configuration, like where you say these are the workloads, these are the observers, the monitors.
I think that makes sense.
Go ahead, Marcos.
Yes. Internally, somebody had a while back had written a version of our stress and monitor test as a single diag, and they called it Stressy. And it was basically just a combination of the SAT and our sensor monitor sort of thing, all as one package that you would just run. And so it is actually a perfect example of that composition concept that had been suggested in the past, of taking multiple diags and turning it into one. But so that is a good potential use case of that, of just leveraging other diags.
The question I would have to that, Marcos, is does it make sense to publish these very thin aggregation layers between the diags, or does it make sense to have a more generic mechanism to compose them?
I don't know. The Stressy concept made sense for its particular use case of this is how we test the cooling system of a compute tray. And so it made sense. But when we wanted to do the same thing, say on a different type of tray that maybe has a different type of accelerator, we didn't just configure the thing to, instead of using SAT, to use accelerators like power virus or whatever load. So we just did all of that separately again, and so we now don't have the concept of Stressy. We now just know we run a sensor monitor asynchronously of running whatever the load is, and that's a more flexible thing, and that's up to the test solution to figure out how to do. So I think that's a more flexible way, is to just leave it up to the test executor, at least in my particular use case. So I'm just saying this is a possible use case for composition, whether not necessarily saying this is we should that would be better than creating some sort of generic way of doing this.
So in your case, the test executor launches the monitoring as in parallel with the workload. Is that the responsibility of the executor?
Yes.
Okay.
So we're able to run these diags in parallel when needed. So
I see.
and for load and monitor, that makes the most sense to me.
All right. So I guess we can continue this discussion another time when maybe Giovanni is on the call as well. Like he had the idea of the composition spec, aggregation spec. I don't know. I'll maybe Vincent. Like I'm throwing a question your way. What do you think about these two items from a manufacturing standpoint? The serial RS-232 item and the CPU performance item.
Yeah, I was going to ask about the RS-232 and the serial analyzers in general. Definitely, I mean, if the question is there value to have a diag, I think it's a pretty loud yes. But the way Igor you presented it, there was some specificity to it that seemed intriguing. Obviously, I think in the criteria for onboarding a new diag, we want to have something as generic and reusable as possible. So if there is constraints on using it or applying it to a specific model or a specific vendor, then it kind of dilutes the value. And obviously there's more work to do, right, to generalize a diag. I don't think we have a very clear sort of ingestion criteria for promoting a diag as a general purpose diag. But the short answer is yes, there's definitely value. Any form of protocol analyzer has value as a diag, I think. And especially open sourcing it like this is very valuable. So I'll pause on this so that, you know, before going into the benchmarking, since I see you have your hand up, Igor, go ahead.
Yeah, so regarding making it general, to make it general, we just do a physical loopback because it will work with any RS-32 adapter, whether it's a PCIe Express card or just a USB dongle. The problem is you need additional steps in testing it, physical steps, and people don't want it. People want simpler solutions such as software loopback, which, as you said, complicates this case because each vendor has their own driver kernel module calls to activate the software loopback. It could be an optional thing, by the way. We can have physical loopback test as a general solution and maybe software loopback as vendor-specific solution that is activated by a flag, for example.
Kieran?
Yeah, so hello, can you hear me?
Yeah, go ahead.
Okay. I think the software loopback is actually controlled by an IR octal, so I think that would be quite general.
Your audio is interrupting a bit, Kieran.
Yeah, it's breaking up. We lost you.
Yeah. So we'll get back on this when you're ready, Kieran. In the meantime, I'm gonna quickly add. I was thinking while you were discussing. I think it makes a lot of sense from a hardware standpoint that we could say this diag needs a hardware bit to test it, but that hardware bit doesn't necessarily need to be like a standard protocol analyzer or anything. It could be just a different implementation of an RS-232 piece of equipment. Like Igor says, it could be like an USB dongle. but at the end of the day, it acts like a reference. So if you trust the reference, then you can use it to test the card, the PCI card. Are you back, Karen?
Yeah, sorry, I was walking from the bus, so I lost the network. So the software loopback is enabled by an ioctl. So I would think that would be generic enough for most RS-232 cards. So I think that should not be particularly a device-specific thing.
I I don't think I agree with you there. Like if you're saying it's enabled by an ioctl, then that is definitely depending on the driver for the card. So if it has a specific driver, then that is specific to the card.
I can point you to this one. So this was an existing ioctl, not the driver specific one. There would certainly be device specific ioctls, but at least this one seemed to be generic enough because loopbacks are quite common. Anyway, I just wanted to mention.
I mean, I guess it could work, and it would be useful if multiple drivers for multiple cards would implement the same ioctl in their driver, right? But we need to guarantee that that is the case.
Yeah, that is true.
Vincent, want to go ahead with the second one?
Yeah, so I think, I mean, definitely for Igor, there would be value in RS-232. The last bit I'll say on this is maybe what you're raising, Igor, around a process for proposing a diag is an item we should pick up as sort of maybe a through the GitHub discussion or something. So an element of for you to bring that up and have a forum to propose that and move it forward could be I think another good way to use GitHub discussions. Yeah, on the spec, the spec CPU or other spec benchmarks, that's another valuable one. I mean, I think very much like what Dylan had done with SAT. Setting aside sort of the discussion on composition of diags, I certainly see value in having the spec benchmarks ported to OCP format pretty clearly. Like, so, but I don't think that this was really the meat of the discussion. To me, like when I read that, I thought, yes, spec in OCP would make sense. We don't have a lot of very standardized spec tests currently in our test plans, but that would definitely be a plus to ingest them. On the discussion of composition versus not, I think this one is more of a case by case. We also do the same thing that Marcos mentioned, running monitors, so running workloads and then running monitors in parallel, and we control that through the test executor. So I think that one is not entirely clear. Having one diag that does it both, or having composition of diags, I would take more of the Unix philosophy of separation of concerns and sort of composition, you know, at a executor level to orchestrate. It's easier to manage and think about and architect, but can see why somebody would write stressy because it's convenient. But it's not, you know, I don't think we should lean in that direction more because it makes it harder to deploy and operationalize in different environments. So better to have the modules and the diags be self-contained and then compose them separately. That's my view.
Right. Thanks, Vincent. So my question is, if you want to follow up, Marcos, go ahead.
Yeah, so just to kind of, again, plus one on what Vincent said here. If I can accomplish the same thing by a shell script, a very simple shell script where I run two things in parallel, then the composition doesn't really buy me more than I can just do myself in my own environment language. If there's more to the composition in such a way that it does some sort of handling that makes use of the subsequent, like the contained diags and more elaborate handling of weird situations or of capabilities or something that would be hard to replicate, then I see a value in the composition. But so that's to me the differentiator. So composition to me needs to have a really good use case of what it would accomplish more than just simply publishing a shell script that executes each one of our diags in a command line.
So that's kind sorry, I didn't mean to interrupt. That's kind of why I'm curious about the proposal that Giovanni had the last time in the composition spec, because I imagine, I haven't discussed any of this. This is just off the top of my head, but I imagine that having this mechanism of specifying how the diags compose and maybe add monitoring on top of that, or different types of units that go into that composition. I imagine that you can also specify how they talk to each other. So for example, in your case, it wouldn't just be, okay, I have a shell script which runs the stress app diag and at the same time looks at, I don't know, CPU temperature through a different command. But it would be more aligned, something which is more aligned to the output spec that we have in the OCP TV. So you have a monitor that actually looks at measurement series being produced by the workloads, or something that has a more rich interface in how they share information, the units in this composition, so that you can get like a diagnosis output out of the whole thing, if that makes sense.
Yeah, that definitely does. So even if it's not a composition, like if I grab two OCP diags and I just blindly run them together and each one is doing its own thing, then we're not adding value. But if I'm effectively using multiple diags to create a new one that provides some additional insight that would be beyond what I could do just by running them side by side or sequentially, then yes, we're adding value and we're creating a new diag.
Right. All right. So I guess we can table this discussion for the moment until we get more people on the call, maybe next week or the week after, and we could go into more detail as to how that interaction could work. And this would cover this performance measuring that we discussed today as well. All right. In the meantime, I have 20 minutes left. Igor, if you want to do a presentation based on your draft document there, you can do a screen share here and speak over that. By the way, there's a couple of people in the chat saying that we cannot get access to the document, including myself. Maybe we can resolve that later.
Right. Dan is not here. He is a decision maker, but we can go over the doc quickly just to introduce the concept, maybe.
Yeah, I think you can do a screen share. Like on
okay. I don't know why it's not accessible. I think I shared it. Anyway, I'll figure it out later. Screen share. Can you see my? Oh, yeah. Can you see my screen now?
Yes.
Okay. So there is this idea of writing diags in Rust. So let me first give some introduction into Rust. First, a little bit about its adoption. Apparently, Google invested 1 million into support of Rust interoperation with C++. Also, Microsoft apparently is trying to rewrite their internal products in Rust. So the language is gaining more popularity even from big players. So it's no longer a language for enthusiasts. Now, there are also important features of this language that we can benefit from, such as memory safety. When we write diags in C++, we always risk to dereference null pointer, access memory that was not allocated, and so on and so forth. Rust makes these problems very unlikely. So you can access unallocated memory, but you have to try to do it. Thread safety is another thing that is important. I think internally we currently have a problem with a diag that uses multi-threading, and there is some lock apparently that blocks this diag and then it runs forever. There is a chance that if we used Rust, for example, we wouldn't have this problem. Now, also compared to C++, Rust has a very nice inbuilt package manager, Cargo, with a well-known versioning mechanism, Semver. So people who are not familiar with it can go and look it up. Basically, it provides rules for giving version numbers to your releases. Also, I have a little comparison of two important features among 3 languages. 2 of them, I mean, we use, sorry? Oh. Yeah, so for C++, we don't have a standard build system, and currently we use Blaze. OCP TV community, for some reason, tends to avoid it. In Python, we have PyPy, and it's a well-adopted package manager by the community. In Rust, we have Cargo. So in a sense, Rust and Python are similar in this aspect. C++ is lacking. Now, regarding build target, for C++ and Rust, we can build small binaries. For Python, we need to include runtime environment. And as far as I know, internally, it's not a problem yet, but it's risking becoming a problem because we apparently include runtime environment for every diag when we bundle them. So this increases the size of our diags a lot. Now, the proposal is to write OCP TV results library in Rust. We currently have Python and C++, and we can benefit from one more language. First, because our existing C++ library has a problem. A few weeks ago, I was contacted by a vendor who couldn't compile it. I tried to compile it myself and also couldn't do that. Apparently, we have problems with our dependencies where they trigger compiler bugs. So possibly upgrading these dependencies would solve it, but upgrading dependencies with Blaze is painful. So I tried to do that and I couldn't. I had some other compilation issues when I tried. So I ended up just cherry picking some patches for libraries that our library uses and applying them on dependency installation step. This means that we basically do not support like all compilers or even like compilers that we just go and download. So I think our vendor just used the latest version and they couldn't compile the library. It's interesting also that the problem was in gRPC library, which I don't know why we need in the results library. Maybe somebody can tell me more information about it. A solution to this would be to write the library in Rust and provide foreign function interface for C++, so that we link a binary that we built from Rust to C++ diags. The benefit of this is that we can develop this in open source environment and better control our dependencies. Also, another reason why we may want to write this diag in Rust is that there is already interest. Meta, for example, expressed their interest. Maybe folks from Meta can elaborate on this if they want to. Another thing is simplicity of installation for the library. Like our vendors, they are not familiar with Blaze sometimes, and we probably want to make library usage as easy as possible for them. And for existing C++ library, well, you need to go through a few steps to do that. And it's a steep learning curve. For Rust, given that the person who develops diag knows Rust, library installation will be simple. So you just create a project as shown here, like cargo new diag, and then you add a dependency. Probably we don't even need to publish this library as a crate. We can just use a GitHub link. Because, well, no, actually we can publish it as a crate also. But if we make diags that have very specific functionality and will not be used by general public, for example, then we can just keep it as GitHub repo. And as you can see, linking a dependency that is a GitHub repo is quite easy. You just insert a link, that's it. You don't need to write scripts in Blaze and so on. One more thing that is important is that we can compile a diag together with the library into a single binary. You can do this in C++, but you cannot do this in Python. And you can probably package Python scripts together with runtime environment. But as I said earlier, it's going to increase the diag size. We can attract more contributors by producing a library in Rust. As I said, Rust community is growing, and there are a lot of interesting projects that people choose to write in Rust. And maybe if we have this library, more people will join the community, though I'm not sure about this. For Google internal resource planning, we can probably make it as a 20% project, because Google is known for this culture of 20% projects. And it's a good way to do research development, for example. Now, we talked about diag composition. And I think if we implement our composition in Rust, we can implement it quite easily. So, for example, if we decide to develop diags as packages in Rust, this package can include two different pieces, a binary piece and a library piece. The binary piece will be useful if you want to run your diag standalone. For example, you have a new machine and you would just want to test if it supports your diag, if the diag fails. But we can also turn diags into libraries with API so that we can compose them like we discussed with running stress tests and measuring information from sensors. Right now, with, for example, our Python diags, it's quite hard to do because our diags are designed to work as standalone applications. So you run it, you get JSON output. In order to use it as an API, you need JSON parser, and basically you need additional infrastructure. If we decide to provide API calls in advance, then the diag can be included in a bigger scope diag, a complex diag. And I try to depict possible use scenario for a composed diag. So here you can see I mentioned partial hardware interface, which can be also a Rust package with two parts, binary, so that you have command line interface to test hardware interface to see what CPUs it gives you. And it can also have API as a library so that diags can use it. For example, here on the diagram, diag A uses hardware interface Y, maybe it provides the list of CPUs. And then it also uses hardware interface X, which maybe provides information about DIMMs installed in your machine. Then below I have this diag composer, which is a higher level diag that user can write themselves. And this diag can invoke other diags API, like run stress test, for example. And in parallel, it would request measurements from another diag, let's say diag B. This higher level diag may need API for composing diags. For example, for combining their OCP TV standard outputs, or to run them in parallel in a nice way, as opposed to manually creating threads. Yep, that's some information that I wanted to share. Any questions?
So we have about 5 minutes for questions.
Right.
I'll start again. So the main thing that I'm seeing here, there's obviously quite some quite big advantages to having the Rust ecosystem. But at the same time, this still implies a compilation process, which was kind of the topic that was discussed with Bazel versus Python, like versus pure Python. Python doesn't have a compilation process, which allows for quick iteration if you need something on the code. That being said, Python, because of this lack of compilation process, also has a big disadvantage in that if you touch code that doesn't get executed when you are testing your change, then you will likely not discover that you broke something until later on, which for a compiled language is a lot more difficult because the compilation needs to succeed. I would ask maybe Marcos or Vincent for opinions on this one, because I think both of you have more experience in Python, in the Python world with diags. What do you think about Rust?
Yeah, I'm happy to jump in unless you want to go, Marcos. All right. Yeah, I'll be quick. So I think the value of having a Rust binding or a standalone Rust is definitely a plus. I would never oppose that. I think in the ecosystem of enabling diag writers having languages like Rust that have a solid hardware software interface is a definite welcome addition. If it came for free, so to speak, that would be clearly a value add. The question I would have, Igor, on this is more around the discussions we've had on Bazel and the C++ bindings, and when we went on to have a native Python native implementation Have you actually given some runway internally with your partners at Google on the Bazel Rust and seen some of the adoption come up? That's kind of a side question that I have around what are you really getting? Because we've had a lot of discussions internally here on the value add of Rust, and it's a very polarizing discussion. There's certainly some camps, but I'm curious to know, are you kind of putting the training wheels and getting a Rust binding through the C++ Bazel builds with the protobuf, or do you want to just go the same route we took with Python native and propose an OCP diag core Rust?
So I meant to implement the library in Rust, compile it as a static library, and just link it. And it does not need to be done using Bazel. It could be just a header file with external function definitions that you can download from GitHub and include into your project and use whatever build system you prefer. Because Bazel, I don't know, maybe it is getting adopted, but I heard some reluctance of using it. Also, you asked about protobufs. Protobufs will not be involved here. It will be binary binding, basically. Yeah, so I hope I answered your question.
Yeah, so you're saying you kind of look at the model of the OCP diag core Python and have an OCP diag core Rust that would be that the community could link their diags to and basically deliver a Rust diag.
Right, either Rust diag or C++ diag if you do bindings.
Okay. Yeah, I'd be interested to hear what Marcos has to say. I know for us, I think it would take a little bit of discussion internally. I'm personally welcome Rust to the family, so to speak. But I think it's for the community to express that as well.
Marcos, 1 minute.
Yeah, no, this is piqued my interest enough to go into our internal training site to go try to take some courses on Rust and learn more about programming in it. So the resistance to Bazel is that works really well in a company that's already using Bazel, etc. But if not, it just the barrier of entry to creating a diag when the alternative was to just do it natively. It's an interest in reducing the barrier of entry. So I think Rust seems like a great thing, and kind of to plus one Vincent here, just if it's there and somebody wants to use it, I think it would be great. Driving adoption and forcing it down like a vendor to try to use Rust instead of something else, that may be harder to find developers on the other side that know Rust, but I think from the ability for anyone to produce a diag, if that's a better use case. Like I always like the pull thing of build something better, and that and that people use it when they're trying to solve a problem. So I think this would be kind of would be really cool to have. Don't know how much adoption we will have early on.
Cool. Thanks, Marcos, and thanks, Igor, also for the presentation. I think we'll continue this discussion next time. I know Venkat from Meta was also interested in having Rust diags, so we have a couple more topics that we can continue on this later on. All right. Thanks everyone for joining today, and we'll see you next week. Bye.
Bye-bye.